So formula that you have to memorize. Let's all write out memorize. And if you're not good with formulas, because it is okay, I am going to share something that's going to help you. Let's all write out senior. Our seniors, right? Senior, Miss, PMS. You're like, ew. That acronym is going to help you figure out what symbolic notation we're going to need. So our first thing is distance is equal to. The senior stands for square root. Square root. And then we have something inside the parentheses. So we have minus squared. So minus squared. And then we have PMS. Any idea what P stands for? Plus. Then I have minus squared. Parentheses kind of does make sense though, right? Because we're using it. So in case on your quiz or test, you're like, well, I forgot where the plus sign goes, where the minus sign goes, write out senior, Miss, PMS, square root, minus sign, squared, plus, minus, squared. Yes? So within that will be x2 minus x1 and y2 minus y1. All right, Luke, let's read example number 1A.
Find the distance between 4, -5, and -2 and -8.
So let's go ahead and label them. That's x1 and y1, x2 and y2. Should we write the formula every single time?
Yes.
Yes, the more you write, you'll naturally memorize. So let's write out our distance is equal to the long square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now let's plug in what I know. What is in place of x2? -2, thank you. What's in place of x1? 4. And keep in mind that minus comes from the formula. Then I have y2 and y1 is going to give us -8 minus a -5. How can I represent minus a negative as one symbol? +5, all squared. And then from here, you have to take it step by step because you'll make silly mistakes. Where did my orange go? Oh, here it is. So let's worry about the first chunk in the inside and second chunk in the inside. So then I have, if I have -6 times -6, how many is that? Positive 36. How about -3 times -3? Plus 9. Now let's combine them. Our distance is square root of 45. Are you writing with me? Writing with me? Okay. So then we have 45. I think about 9 and 5. Isn't 9 a perfect square of 3? So we have 3 radical 5, and we are done. So make sure you write out the formula, plug the numbers in correctly, and simplify by its chunks. Don't try to do more than one at once. All right. Let's go to 1B. Tyler, let's read.
Solve for x if the distance between x and 5 and 3 -2 is 10 units.
Okay. I think I'm going to change this problem up to make it friendly. Instead of 5, I want you to put in 4. And let me make sure it works out. Yeah, that's going to work out. Let's label this x1 and y1, x2 and y2. And 10 is our distance, as in letter D. So what should we always start with? The formula. Thank you. So we have square root of x2 minus x1 all squared plus y2 minus y1 all squared. Let's plug them in. We know our distance is 10. Square root. What is my x2? 3. And then we have minus x all squared plus, what's my y2 and y1? -2 minus, not 5. The original was 5, it was 4. Yeah, I'm changing it up so the number turns out prettier. All right, let's go do some quick recall on this one. What should I do on both sides to get rid of that long square root?
Square.
Square the whole thing. Now here's what some of you guys might do that is mathematically incorrect. Some of you guys might say, I see a squared, can I get rid of that square root? You cannot because it is separated by a plus or a minus sign. Just keep that in mind. So this square root is going to cancel that one. So I have 100 is equal to 3 minus x all squared. And let's go ahead and compute the inside. What is all that going to give us? 36. So if I apply algebra 1, minus 36 on both sides, what do I get? So we have 64. Is that 64 a clean number, kind of?
Yeah.
Because when I square root this, what do I get? Okay. So we have 3 minus x, since they cancel, is going to give me 8. And then, how about I move the x to the right and move the 8 over? Y'all see that? So if I move the 8 over, what do I get? Negative 5. And I think it's normal to say x equals. So if I kept it as a 5, that won't be a perfect square, so I kind of changed it up, okay? All right, example C is something kind of different. We're looking at a fractional value. So Abby, let's read 1C.
Find the point that is 2/5 of the way from 2,4 to 12, 15.
All right, for fractional values, I want to look at just the x's first. Go ahead and circle the x's. And I think visuals are helpful, so why not go ahead and draw this? Here's 2 and here's 12. So if it is from 2 to 12, how long is the segment? 10. And it says I want 2/5. So if I take 10 times 2/5, let's see what that's going to give us. What is 10 times 2? 20 divided by 5? 20 divided by 5? 4. So then, if it was starting at a 0, it'll be 4. But what number am I starting at and going 4 units? So if I go 4 more from 2, we get 6. It'll be 4 if I'm starting at 0, but not everything starts at 0, right? The next piece, for the y values, let's go ahead and say I'm starting at 4. I end at 19. How long is the segment for the y value? 15. So I get 15 and 2/5. So what is 15 times 2? 30 divided by 5. So we're not starting at 0, we're starting at 4. So the actual value of the y coordinate is 10. I think visually this makes a lot more sense. Okay, let's make a coordinate plane with the x and y axes. Where must quadrant 1 go? Top right? Does that mean quadrant 2 can go on the bottom? 3 and 4? What letter do you, if you remember, maybe if your teacher used it, letter C, very good. It's in the direction of letter C. So that means quadrant 1 is on the top right, quadrant 2 is on the top left, then 3, then 4. And I want the best answer possible. So if I were to plot 2, 8, which quadrant am I going to land at? 1. Okay, let's partner up for the rest of them. Talk to your neighbor. Talk to your neighbor.
3.
9-0.
Let's see.
One in first, but I don't know which one.
Oh, wait,
Oh, wait,
it
it's
could be.
postponed.
It could be. I'm gonna say one
Say
in
one.
0. I mean, one four.
0, 0. 0 is neither positive nor negative. And 0 is the origin.
Oh, wait, so.
4 could be all. That's 0, 0.
Yeah.
So where would it be then?
0, number 8.
Mm-hmm.
Like, is this one, if it's like on the line, would it be like, which one would it be?
X or Y axis.
Or maybe it's both.
Mm-hmm.
Wait, wait.
So you're right, X axis or Y axis.
Okay.
5 is 2. That one's 3. Oh, that one is not a line. Oh, you just put on the axis.
For 0, 0, but just put X, Y.
Origin. Mm-hmm.
I don't know. I left 5.
All right, I'm ready. If I plot negative 21 and negative 78, which quadrant? 3. If I plot 9 comma 0, I don't want to hear between 1 and 4. Where is it specifically on? What axis? X-axis. So switch this if you wrote between this. What about 0, 0? What's a specific name for that one? Origin. What about 4, negative 9? Quad 4. And then negative 45, 34. Quad 2. And 0, negative 8. Y-axis. Hopefully that didn't sound too new. Okay? We have one last problem on the back.
I just wrote axis.
All right. Example number 4 is the last one. So if your neighbor's talking, tell them, be quiet. So we had distance formula on the front. All right, for this one, we're looking at distance between 2 points in a 3-dimensional manner. So all that basically means the first two chunk is the same. The last one has our z-axis. So let's go ahead and write out x1, y1, z1, x2, y2, z2. And yes, let's write out the formula. So it's the same behavior, except we have a chunk with the z's. x2 minus x1 all squared plus y2 minus y1 all squared. Now row 2 again. And then z2 minus z1 all squared. So let's go ahead and plug in the values from our coordinate plane, or the points. What are my x2s and x1s? 12 minus 0. And no, you don't have to write the 0. What about y2 and y1? 1 and 9, 1 minus 9 all squared. What about z2 and z1? Negative 3 and minus 5 all squared. Notice it says the nearest thousands. We're going to just leave it in simplified radical form. Let's circle our chunks. Hopefully we know what 12 squared is. 144. So we have 144. What would the second square give us? Plus positive 64, correct? And the third square? Also 64. So when I add 144 plus 128, it is 2 something. 270. Ooh, 272. Let's write that off to the side so we can simplify the radical. Now 272 is kind of a big number, right? But it is an even number. So let's go ahead and take it simple and cut this in half. That gives me 136. If I cut that in half again, what do I get? 60 how many? 8, thank you. Cut it in half again, what do I get? 34. Can I cut half? And I get 17. Let's circle the pairs. I have a pair. Do I have another pair? Sure do. And then the radical 17 is not a pair, leave that on the side. Which part can I further simplify? 2 and 2, so 4 radical 17.